All right, what we're doing here is they're telling you this is a third-degree polynomial. That means its leading term has to be a cube. And they're giving you 2 with a multiplicity of 2 and -5 as factors in it. So that means factors-wise, we've got x. If x equals 2, then x minus 2 is a factor. Okay. If multiplicity of 2, then that means you've got that as factors. The -5, if x equals -5, then x plus 5 is factor. Okay. Now, the implications of all of this is that means we've got x minus 2 squared times x plus 5 equals 0. Or another way of looking at this is x minus 2 times x minus 2 times x plus 5 equals 0. And what this is asking you to do then is this is asking you to multiply that thing out and get the original equation. This time we've always up to this point, we've started with the equation and worked down to the x equals. Now what we're doing is we're starting with the x equals and going backwards to find out what the original equation was. Okay? So that's what this problem, this wording, is asking you to do. Well, we got to multiply these two. You do this business, and you're going to get x squared minus 4x plus 4 for that part. We've still got to multiply it by x plus 5. Okay? So, that times that is x cubed. That times that is -4x squared. And that times that is plus 4x. Now we got to take the 5 times the first term is x squared, or 5x squared, excuse me, times the second term gives me -20x, and times the last term gives me plus 20 equals 0. Okay, that's what this language is telling you to do. Does that, any questions on this? Okay. So if you see this language, write a polynomial, that's wanting you to take the points on the axis, convert them to factors, and then multiply out the factors. That's kind of your sequence that's always going to happen on this kind of problem. Now, could we grade this? Could we graph this thing? This doesn't ask us to do it, but can we? Because eventually you're going to need to anyway. Well, yes. This one gives you a factor of 2. Okay. And we know that it is a touch and go because of the even multiplicity. Okay. This one gives me a factor of -5, I mean a 0 of -5, and it is a odd multiplicity, so it's going to be a crossing. Now, this is a third-degree equation, so that means they generally go like that if that's a positive, or up and down if it's negative. So that means that we know that this has to come up like this somewhere. We can find the y-intercept, 20, way about up there. So this thing's going to go up like that. And I'm not going to draw on that stuff. And then it's going to come down like this. And it's going to turn and go back up again. Okay. Does that, you see how I did that graph? That's the basic odd power thing. Your endings starts low, ends high if that's positive. And because of multiplicity, this one just has to turn. This one crosses. So we can draw that graph. And then using the y-intercept, we know that it would touch the y. What probably is going to happen is this thing is going to hit that at 20 and still go higher and then come back down, so that this thing's kind of symmetric along maybe that line. Now, that's a probability. How would I know exactly? Do an XY table. Okay, pick some values of X. Pick -4, -3, -2, -1, 0, +1. And you can get the Y values exactly where it is if you want to. Okay. Any questions on this stuff before I erase it? Yes.
The 5x minus 20x plus 20.
You share it.
Yeah, that correlates with the blue lines. I was writing it down when we were doing that.
Okay.
So the x plus 5 times x squared minus 4x plus 4. You just walk through
This,
yeah,
how I got that?
Yeah.
Okay. Well, actually, I've got it right here, except I'll just use multiple colors. Do you understand how I get this out of that?
Sure.
Okay.
It's the 3 times the x plus 5. The x squared minus 4x.
Oh, you know what? I didn't finish this problem. My bad. I gotta add these. There's the answer. This, to get this value right here, what I did is I took this x times that x. I'm distributing.
Sure.
And I got x squared.
Right.
I took this x times -2. Okay.
Negative 4x. Right.
Okay, which is -2x. Then I took this -2 times that, which is -2x more, to get the -4x. Then I took these two 2's together to get the 4.
Right.
Okay.
The next step is where the x plus 5 times that triangle.
I basically used the same process, except I did it backwards, and instead of going this way, I went that way. I took this x, in turn times all three of these.
And then 5.
And then I took the 5, which is my blue marks, in turn times all three of these. And then I should have added it earlier. Nothing in this, that's still the y-intercept, so everything I said about that's still true.
Okay. Thank you.
Well, thank you for causing me to finish the problem. Okay. They're actually going to do the same thing that I just did. See, here's that step where I multiplied that out. Now, here's this step where I took those. And then here is where I took those. And it comes out what we did. In this particular case, they worked it exactly the same way I did. Okay, apply the rational zero theorem. That's what it says. If you got one of these, okay, comparing this to that A would be this 4. There's the X. And this little number just says that it goes with the first term. This one says it's 1 behind the first term. This one says that number is 2 places behind the first term. This means down here, this is the next to the last term, and that's the last term. Okay? That's what this generalization means. So here you notice the powers decrease by 1 every time. 3, 2, 1, 0. Okay. So that's what that's showing that. That's what that means. I have shown you guys this. We've done this. I started this the other night. I actually skipped this slide and I went to one of these and we figured out what are all the factors of this. Well, the 15 is the most important thing. The factors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15, right? That's just like when we were factoring, we had to figure out all the possible pair numbers. Well, then you can also have the factors of the leading term as a division. Now, here are these. And I'm going to use my own, I know I taught this, but I want to go over it one more time. I'm going to do this problem again. Here, I've got plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Now, what this means that these are the possible factors is when you do this business, whatever the signs might be, these two numbers, if this is a quadratic, have to involve those. Like, for example, you could have 3 and a 5. Okay, that gives you 15. Now, that's kind of an oversimplification. Ultimately, what we're doing on this, you know, I told you that both long division and synthetic division are a way of factoring a higher degree polynomial to get it down where you could get the answers. Okay? Ultimately, this is telling you what numbers that are worthwhile to try to long divide or to synthetic divide with. It's giving you it's narrowing the number of guesses as what works. Okay, now where this comes in, the factors of 4 are, I'm going to write them under here for now, are 1, 2, and 4, plus or minus. Now, what this thing means is we got to take these and make the fractions correspondingly with these different denominators. The 1 is a non-player because it ain't going to change anything. But we do have to deal with this 2 and this 4. So we could, in addition to those, we could also have plus or minus 1/4, or 1/2 rather. We could have plus or minus 1/3, or 3/2 rather. We could have plus or minus 5/3, and we could have plus or minus 15/3, but 15/3 will reduce to 5, which we've already got, so we don't have to list it again. Okay, I'll leave this here as 15/3, but I'm going to put the note reduce to 5. Okay. Now let's do the same thing with our 4s. I can have a plus or minus 1/4. I can have a plus or minus 3. Oh, you know what? I did something wrong here. This should have been 3 halves. This should have been a half. That should have been a half. I don't know where I started writing the 3s from. And this no longer applies. No wonder you guys had that what the hell look on your face. I'm sorry. Okay. Now I'm doing 4s. So hopefully I won't get off on track again. That one over 4. And this one over 4. Now, what that means is if we took this equation, 4, -13, -32, -15, and tried to do a sign, help me out, synthetic division, that means over here, I could try any one of these possibilities. Okay. Now, is your first guess going to be one of these? Heck no. Your first guess is probably going to be plus or minus 1. Okay. Let's go -1 as our first guess. 4. Okay. Multiply -4. -17. Multiply +17. 12 minus 7 is 5. 2 minus 1 is 1. So -15. positive 15, remainder of 0. Good guess. Because you want to get a remainder of 0. Because what that means then is this equation is now changed into, hey, we got to put in our terms here. This one was x cubed, right? So this one will be x squared, x number. So now what we've done is we've changed this problem into 4x squared minus 17x minus 15 times x plus 1. Okay. Basically, what we have done is we've taken one of these, I made a lucky guess, and this process actually factored that down 1 degree. Okay. Now then, where do we go from here? Well, this one, we can either try to factor it, we can try the synthetic division with another guess in here, okay? Or we can use the quadratic formula, which will give us the answer for sure, instead of a by guess and a by golly. I might try 15 into this thing, okay? And it might be right or it might be wrong. In the process, I've done this much work on a guess. Or I might try a 3 and a 5. Or I might try one of these fractions to do this process. But once you've got this down to a square, you can use the quadratic formula and you know you got it right, without all the guessing and working it multiple times. So we're going to do that. We're going to take x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The basic formula that we've covered previously. Okay. Negative b. Well, that's negative 17. Plus or minus the square root of negative 17 squared minus 4ac. Well, a is 4. C is negative 15. All over 2 times a, which is 4. Okay. We continue on. This becomes positive 17 plus or minus. Someone take your calculator and square negative 17. Hit negative 17, hit the x square button. Okay. That's what I thought it was, but I wanted to verify. Why did I think it was 289? Because 7 times 7 is 49, and it's got to be a 9 on the end. Okay, and I've gone through that perfect square list, and I kind of know where I recognize the numbers, but I had to verify it, and that's how I will verify it. So 289, and that 289 is going to be positive, because if you square that negative, then it comes out positive. Minus times minus is plus. Okay, 4 times 15 is 60. 60 times 4 is 240. Isn't it easier doing that than 16 times 15? So plus 240 all over 8 equals 17 plus or minus square root of 9, 8 and 4 is 12, 2 and 2 is 4, carry 1 is 5, okay, all over 8. Now, is 529 a perfect square? What, someone do square root of 529?
23.
23, okay. I'm gonna go sideways this time. 17 plus or minus 23 over 8. Okay, this generates two answers. It generates the positive side and the negative side. 17 plus 23 over 8. And then it also generates 17 minus 23 over 8 equals. So you do these two. This one, 7 and 3 is 10. 2 and 1 is 3, and carry 1 is 40 over 8, which gives me an answer of 5. X equals 5. Over here, this gives me negative 6 over 8, which is negative 3/4. Ding. Okay. So that means this is a factor of that. That's a factor of that. Positive on this case, negative on this case. And that's a factor of it. These are the 3 zeros, the 3 graphable points on the graph. Negative 3/4 right here. There's 1. Negative 1 itself right there. And positive 5. Third degree equation is going to go like this. So that means this thing has to go up some amount of high. We haven't multiplied it out, so we don't know. Because knowing these two things, this gives me the factor of x minus 5. This gives me the factor of x plus 3/4, right? Or 4x plus, minus 3. Okay, what does that mean for this thing? That means this becomes x minus 5 times x plus 3/4, or we could rewrite that as 4x minus 3 times x plus 1 and here are my 3 factors that make up that equation. Now, if I wanted to know the original equation, this doesn't ask us to do that. But if I wanted to know the original equation, then I would have to take this times either form of that times this, multiply it like we did on that last problem, okay? And get the equation. Now, do you want me to pursue this and take it all the way to the equation? Because I'm willing.
I think you get the 4x.
I'll go over here. X, you understand the x plus 3/4.
Yeah.
Okay? If this equals 0, then if I take that 3/4 over to the other side, I would get x equals negative 3/4, which is what we had here. Now, if I want to take this back to this kind of a form, instead of just bringing the 3/4 over here, I could multiply this by 4 over 4, or multiply this by 4, multiply that by 4, to get rid of that, which would give me 4x equals negative 3. Then I've got to take this over to the other side, 4x plus 3. And I made a mistake down here to show that I lost. And this should have been, well, I had here, yeah, that should have been a plus. Okay. But that's how I did that.
Maybe it was a minus and it's still.
Yeah, well, probably was. Any of this makes sense? You see the process. All this is a method of factoring when you've got higher degrees. Okay, we took it down a degree. Now, if we started with a 5th degree equation, we might have to do this process 3 times to get down to a quadratic. Okay, and that's where this becomes important as to what are your possibilities. Okay. Now, the only thing I didn't do on this is I didn't multiply these 3 terms out to get the equation. That's the only other thing you could do on this problem. And wow, that's a bunch of stuff. Now let me erase all of this. And actually in this one problem, I've taught about 90% of today's objectives. But we do have to deal with radical roots and imaginary roots, which we had not done yet. Well, actually, we did one. I think it was had a square root of 5 in it. And on radical roots, I told you if there was one, by radical, I mean like square roots, cube roots, that kind of thing. I told you if there is one, then its conjugate also has to be there in the solutions. Okay, I'm just going to run through this slide real fast. I didn't want to use their numbers because they didn't sequence these large, small to large. And to me, it just works better if I sequence them small to large. Okay. Find the zeros in their multiplicities. This is close to what we just did. Here are the factors of 3, the factors of 2, and all the possible factors. Same process we used last time. We took these, one's a non-player, so then we had 1 over 2 and 3 over 2. So those are all the possibilities you could use in this problem. And that's all there. Okay, now what we're trying to do is we're trying to factor this down 1 degree. They're going to make a guess that positive 1 is one of the roots for this thing. They're going to make that guess because it's on the list. They could have tried -1 just as easily, like I did before. So they're trying +1, they get it, and they get a 0 remainder. That means it works. So now what they've done is they've changed this into, I don't know what power was this thing to start with. 4th. So now they've got a 2x cubed and a x plus a 3x squared minus a 2x minus 3. So they've got that times x minus 1. Because remember, this is always the root compared to the factor. So we have factored this thing down 1 degree right now. Now we need to do the same process again and factor it down another degree, so we've at least got a square so we can use the quadratic formula if we have to. Okay? So we got to use this same process. Well, what are our possibilities? We still got the same ending term and beginning term. That's coincidentally, it won't always happen. So we've still got the same set of possibilities for divisors or for roots. Well, what do you want to try this time? Honestly, I would try either a 2 or a 3 is what I would try, plus or minus. Take your choice. Well, let's see what they try. They decided to try 1 again. Okay, that's possible. There could be a touch and go point in this graph. Well, they're trying 1 again. And ding, it worked. It worked. So now what we've got is we've got 2x squared plus 5x plus 3 times x minus 1. Okay. Whoops, let me put this one in. Well, that one is x minus 1 times this x minus 1. And that's what we got this thing down to now. Now we can either try to factor this manually using my cross product method, or you can just throw this into the quadratic formula, get the answers, and then pull them back to factors. You got kind of a choice. Well, let's see what they did. Okay, here they've got same thing that basically I wrote. Okay. Now, what they're telling us is that they factored this and got those 2 terms. Okay, that's what they're telling us. This one, to kind of go back to what your question was earlier, could be written as x. Let's see. Take that over. It's going to be minus. Okay, if x equals, take that over, it'd be minus 3 over 2. Then take this whole thing back over, so it would be x plus 3 over 2, like so. Okay. This term could also be that term. You're cool with that term? Okay. So this or that would be your answer. Now, the advantage of this one is it's easier to graph than that one. to graph this thing, which the problem does not ask us to do, we've got factors of +1, +1. Okay, that means -1 here. Factors give me the opposite. And I know that this one is a touch and go one, a turning point. Okay, either this way or that way. I don't know yet. This one, +3/2, gives me a point right here. -3/2. Here's 1. Here's 2. Okay, so that gives me that point. This and that one is a crossing because there's only one of them. And that point gives me a point here at -1. Uh-oh, I screwed up. Let's go back. Well, here's 1. These two give me +1 in both cases. Okay, now do you understand, since I've corrected myself? This one gives me -1. Ultimately, I would have had the right points for the wrong reason. Okay, now I can graph this thing. This is a 4th degree equation that we started with, right? Fourth degree equation with a positive leading term. Okay. Now they talked about multiplicity, but we already did that multiplicity business. That's why I said that this one is a turning point, except I said the wrong one is a turning point. It's this one over here. Turning point or touch and go. And both of these are crossing. Okay, because there are only single incidences of them. This thing has to go up and up for its final endings. Its 4th degree is an even power, which is always this or this, maybe with bumps in the middle like my knuckles. Okay, any even power is always this and this or that and that, depending on whether positive or negative leading term. Because it was positive, I know that these two endpoints have to do that. Now, what's this thing going to do in the middle? This one is a touch and go, so if it's coming this way, it's got to go back that way. Okay, does that make sense? And ultimately then, what this is going to do, I need a different color of this black. Then here, if I found my y-intercept, if all these x's were zeros, I would have -1 times -1 is +1 times 3/2 is 3/2 times 1 is still 1. So 3/2 is my y-intercept. So I'm going to go up there. And then because this is crossing, I'm going to come down and back up this way. Okay. Now, how far down? Well, I'd have to do an XY table halfway between these to get a good idea. The only reason I knew this one came here, actually, this probably comes a little higher, more like that. So you can find out exactly high by doing an XY table at probably -1/2. You'd find out what it is, probably 2, I guess, but I don't know without actually doing it. Substituting -1/2 for x. And over here, if this is 1 and that's 3/2, then halfway between that would be your point you try over here. Well, what's halfway between 1 and 3/2? So it would be 5/4 would be halfway between them. Which would give you that line of symmetry for that dip. And you could just try that in if you wanted to be precise. But you know what? For this course, 90% of the time, graphing these 3 points, finding the y-intercept, use your end values and draw approximately. You're not going to get counted off if you're 1 point off here. Because all our instructions typically say sketch. Okay. So you can get a close idea of what the graph is. Now, this is the full range of skills on this. Any questions on this one? The only thing I did do is I just did finish multiplying all of these out to get the original equation, which actually, if I multiply these out, the equation I would get is that. If I multiplied all those out, I would get this with a whole lot more work. So why do I don't need to multiply them out this time? But I did need to bring them down here so I could find out what the factors were so I could graph it. Now, that's the way the system works. I would say good, bad, or ugly, but it's mostly ugly. A lot of computation. But the main thing that I want you to understand out of this whole process is that scientific, or not scientific, that this kind of division, synthetic division, is nothing more than a long-winded way of factoring a higher degree. Okay? That's the important lesson I want you to get out of this. Okay? All right, let's go on. Well, here's another one. I'm just going to run through it. Here you can see they're taking this equation and putting it in the quadratic like I did earlier. So in this case, they get 2 radical ones. Okay. Now, whoops, let's go back to that. So in this case, we got 5 here, and then we got this business. So what do our solutions look like on this problem? Our solutions on this problem are we've got x minus 5 from this, and we've got that -3 plus radical 5, and something a little over color that. -3 plus radical 5, and -3 minus radical 5. here are your factors on these. That's a real number that is graphable. If you get your calculator out, bunch of stuff loaded while we were doing. Oh, crap. Over here. There it is. Okay. -3, -3 plus square root of 5 equals. Now, there's the decimal value. Oh, I'm sorry. Let's bring this calculator. Oh, this computer isn't going to let me display that calculator because I don't have that calculator license in that computer. So, but hopefully you can put in this value right here in your calculator in that same order, okay? And the value that you're going to get is 0.763 something. So basically, if you tried to graph that, this thing, you would have the 0.76 something. Here is 1, so it'd be about roughly 3/4 of the way. Then you would have to change this. You don't rewrite all of this in your calculator. You use those arrows up at the top until you get right here. Delete that plus, and put a minus, and you can get the negative value. So I'm going to do that even though you can't see it. I'm going to put a minus in there now. And I'm going to get my equals. And use the SD column. And for this, I get -5.236. -5.236. Over here, I got +0.760 and some other stuff. And this, I get 5. X equals 5. That number. And that number. Okay. So there's the 760. Here's the -5. Here's 5. So that one would be right there close to it, but not touching it. And this one would be +5 out here. Okay. So there's my 3 points. What kind of equation degree is this thing? 1, 2, 3 degree. Oh, I left something out of this. X minus this, and X minus that to get my factors. Okay, now, if I graph this thing, 3rd degree, that one's got to go down, this one's got to go up. It's basically going to do that. Okay. But as you see, one thing I want you to know is anytime you got a radical, you got to have its conjugate. Okay. That's the important thing out of this. Okay, here's another one. Write a polynomial of degree 3 that has these zeros. I've already taught you this because it has a multiplicity 2. That means you're going to have to use it twice. Actually, we worked this particular problem already. We actually worked this problem. Remember talking about it earlier? So that particular problem is repeated. Now, with imaginaries, this is something new. With imaginaries, if you got one of them, you got two of them. You've got its conjugate, okay? And in this case, we don't know what the A term is because nothing up here gives us an indicator. So we got x minus 3i, x plus 3i, and x minus 2. Multiplicity 2 means squared, okay? Now, these two are conjugates. X squared, ordinarily you would have minus 9, but I times I is I squared, which is -1, which is what changed this to plus. This one, just like before, multiplies out to that. Now we've got to distribute this x squared and the 9, okay? And, oops, you get all of that stuff. Now, there could be some leading term number that you don't know. But for right now, we'll just leave it as an unknown, okay? Now, this tells you something that I already told you. If you have imaginary or complex coefficients, if you got one of them, you got both of them. And it's conjugate. And now they're actually calling it conjugate there, zeros there. Just says if you got one of them, you got its conjugate also. Now, something tricky about these. If you have a root of -3 plus 2i, and you got its conjugate, x equals -3 minus 2i. If you want to change those two factors, okay, if you want to change those two factors, you're going to take this whole thing over to the other side. Okay? When you take this whole thing, you're going to subtract it, right? When you take the other side, you do the opposite side. So what you're going to have is a factor then. Oh, that's just lovely. Fortunately, that one's still on, but kill that one. We'll finish this out without the slides. Okay. Now, in this case, you're going to have x minus all of this. And in this case, you're going to have x minus that. Now, you can multiply these as they are, and it can be a hassle, but the best thing is to simplify this a little bit first. Okay. In your packet, I have a handout on doing this process the hard way. But I don't necessarily recommend that way that I've got in my handout in your packet. If you had to do this, and let's say you've got an extra x minus 1 down here. Okay, let's say you had that. Now, that being said, I would simplify this so I don't have nested parentheses to deal with into x plus 3 minus 2i. I just simply distributed that negative. And this one, I would simplify to x plus 3 plus 2i. Then I've got the x minus 1. Okay? These are easier to deal with than that. Now, what do I do next? I do a 3-way distribution. The x with all 3 of those, the 3 with all 3 of those, and the negative 2i with all 3 of those, and add them up and see what I get. Let's take this over to this side. Okay, so I've got x plus 3 minus 2i and x plus 3 plus 2i and x minus 1. By the way, before we go any farther, is there anyone who has a question about how I came from this to this? Because that's key, that's important. So if you're not sure how I came from this to this, you need to ask me right now. Or let me know and let me try to explain it maybe a different way. John? You look uncertain.
I'm more uncertain about where that x minus 1 came
I just made this up.
from. Okay,
Okay, you've also got a value of x equals 1.
okay.
I'm sorry. I thought I said that. Yeah.
Maybe I missed that.
Okay. These are your 3 roots. Okay. Now, so I've simplified this line. Okay. Now I'm going to multiply those. I'm going to take this times that is x squared. I'm going to take this times that is 3x. And I'm going to take this times that is 2xi. Now I have to distribute that 3 everywhere. I take this 3 times that. Okay, that gives me 3x, a positive 3x. I take this times 3. That gives me a positive 9. And I take this times the 2i, and that gives me 3, 6. I'm going to scoot this plus 9 down a ways. Plus 6i. Everyone with me so far? Now I got to do my third distribution. I'm going to go on the bottom this time because that's getting crowded up there. Negative 2 times x is negative 2xi. Negative 2xi. Let me put this on the third level. Negative 2xi. Okay. Oh, now I'm going to do these two. And I get negative 6i. And I'm going to do these two. And I'm going to get negative 4i squared. That's a new term now. Okay? I add all of this together. And what do I get? I get x squared plus 9x. Those two cancel. These two cancel. Minus 4i squared plus 9. All of that is still times the x minus 1. Okay? Did I make a mistake somewhere? Where?
So we added, right, so that was 6 instead of 9.
Yes, thank you. Well, I don't know why. All right. You know what I did is I multiplied them instead of adding. What? Don't ask me why, but I did. Okay, so I got this. Actually, this can be simplified. This part. Because I squared is -1. So this means, actually, this is plus 4. So this thing becomes x squared plus 6x 9 and 4 are 13 plus 13 times the x minus 1. Now, why did these terms drop out? Because I had a conjugate to start. Okay. So now let's multiply that thing. I had x squared plus 6x plus 13 times x minus 1. Okay, I'm going to distribute. You know what? It's faster to go the other way. Distribute 2 terms instead of distribute 3 terms. So I'm going to go this way, and I'm going to get x cubed. And I'm going to go this way, and I'm going to get plus 6x squared. And now this, and I'm going to get 13x. Now then I'm going to distribute this -1 here, and I get -1x squared. Here, and I get -6x. Here, and I get -13. So I add all of this stuff. And that gives me x cubed plus 5x squared plus 7x minus 13. That is the equation given the factors that you have. In this case, the original, they told you x equals -3 plus or minus what I, 2i, and x equals 1. Okay. This is what they gave you originally. They only told you the plus side of it. But because of the conjugate theorem, you had to have both sides of it. And then you have the 1 here. You do all this multiplications, distributions, and that's what the polynomial was. Okay. So we've really hit some kind of hard stuff today. I think all of you will agree with that. It's a lot to do. It's a lot to think about. Okay, in terms of where we are and where we ought to be. The only thing that we did not get covered today, this week, are polynomial inequalities. Okay? Well, the only difference that you work it mechanically the same way, except then you just have the symbol on the end. And then when you graph it, if you graph it, okay, you only consider parts above the line or parts below the line. And which we did earlier on systems of equations. We'll catch up on that on Monday. Take a look at this and tell me Monday. I'll look at your grades on Monday also. Try to do it all. See if you can get the inequality part. If you're struggling with the inequality part, then we'll go over that on Monday. Otherwise, we'll see where we are. And if I have to, I can give you either individual or a group extension, but give it a try, see what you can do with it first, okay? All right, have a good weekend.